Okay, we are online now. We can start.
Hello and good evening to everyone. This is the first of our lecture this semester at TU Dresden. My name is Bernd Schmutz and I'm running the unit together with Thomas Buck, who is here with me. And we welcome everyone in Dresden, our students, everyone from TU, but of course also everyone from abroad who's listening. And especially we welcome Sama Islam, who's joining us from London tonight to give a talk on material cultures and the practice that she's doing. Hello, Sama. It's great to have you here, and thanks in advance already now for joining us.
Hi, thank you so much for having me.
It's really great to have you here because the work you're doing has a real urgency, I feel, and a universal interest. These times are times of change, and I think that's probably a good way to sidestep new ways of thinking and construction techniques into the culture of building. And it's very special in how you're doing it, because you're doing it with research, with your practice, but on an architectural construction, but also on a cultural and social level. And I guess this is also why for us it feels very important as a unit. This semester we are tackling a large garden in the center of Dresden, which has been a formal Baroque garden, and we're speculating on how a big park in the middle of a city could change, and what local processes could have as a meaning to foster and to unfold these changes. Because ultimately we want to intervene in a few conditions, and that's in the botanical garden, to add new buildings, but also in the zoo to rebuild and transform the zoo, and hopefully also to tear down some of the fences, but also in the park as a whole. And therefore, I think we want to learn from how you question the relationship between building and nature, and how people, plants and animals could coexist in our world today. So we are very excited to hear your talk. And before we hand over, Thomas will give us a quick insight on how you work as a practice and your persona. Thanks.
Yes, thank you very much, Bernd. Very warm welcome from me as well. Sama, we've been friends for many years. I'm very happy you're here this evening. You found time to talk about your work. Thank you very much. I'm going to do a very quick introduction. Some of you studied at the AA in London. Then you worked at 6A Architects. You were an associate there before you started your own design practice, Studio Abroad, in 2014 with George Massoud. And then in 2019, you founded Material Cultures with Paloma Gormley. I think out of like a shared interest in sustainable construction methods and the materials we need for that. Material Cultures is a non-profit organization. You are working in different fields. You're doing large-scale research projects, you're doing design projects, and you're also teaching. Teaching is a very big part of Material Cultures. You previously taught at London Met, at the Bartlett, and now currently you're teaching at Central St. Martin's. And yeah, I think Material Cultures is like trying to combine all of these different fields and aspects in order to find ways and develop methods towards a post-carbon built environment. So thank you very much for being here, Summer, and the stage is yours.
Oh, thank you so much. That was a fantastic introduction. And thank you both for having me. I'm really pleased to be here. Can you see what you were supposed to see? Great. Okay, well, I will start. So yeah, I'm Summer, and I'm a founding director of Material Cultures, and I run Material Cultures alongside my partners Paloma Gormley and George Massoud. We're not for profit, as Thomas said, and we're a research and design organisation, and we work at the intersection of natural materials, low embodied carbon construction, and construction technology. So our work encompasses advocacy through design and curatorial work, where we can demonstrate the beauty and adaptability and also the practicalities really of working with low embodied carbon materials, as well as the extraordinary impact that they can have on the thermal performance and embodied carbon of our building stock. And we teach currently between the three of us, that's across Central St Martin's and also the Architectural Association. And this is a project we finished with our students last year called Carbon Copies. And for this project, our MArch students looked at the impact of translating a series of iconic residential typologies, which exist today in London, into a fully bio-based and low carbon material palette. And then they built fragments of them at 1:1. So on the left, you have a detail of the party wall in the Eric Lyons span house typology, remade predominantly in Adobe and timber. And on the right is an example of the Waterscow self-build method made in kind of bio-based palette with very thick walls, which kind of adapt to regional insulation stocks. In this instance, I think it's built with cork. We build experimental structures which explore low carbon building systems. This is a project we built in the Lake District in Cumbria in the UK. It's an outdoor classroom, and we used structural foundations of dry stone walling and boulders chained to the rafters of the timber frame structure in lieu of concrete foundations. So looking at ways that you can start to make buildings meet the ground without, I guess, the fallback, which is always for concrete these days. And this is a structure which is designed and built by students at the London Met alongside Paloma and her colleague David Grandorge. And in this, they looked at using acetylated timber stilts as foundations. So the connection of the building to the ground is timber, but the timber has been essentially pickled to remove the moisture and prevent it from rotting. And so it's an experiment really to see how that building will bear up over time. We also design demonstrator buildings, which are prototypical and can be applied at scale across new build developments. So we think with every instance about the impact of that typology, and we work with our clients to develop offsite fabrication strategies for their projects, which work with regional and bio-based material supply chains. And our work also encompasses research into materials and their application in construction, but also crucially on their impact on our culture and on our landscape. So we look in our work to support systemic change in the construction industry. For the last 50 years, we've been using crude oil to try and solve the problems of sustainability in architecture. And the realization that this type of sustainability is short-lived has finally dawned. And it's in this context that we established Material Cultures. Our construction industry has produced a multitude of oil-based insulating and high-performance products made from polyurethane and polystyrene insulations and nylon thermal resistors and PVC air tightness membranes, all extraordinary products in their own way. And we developed construction technology using materials like steel and aluminium and glass. And their availability is dependent on vast quantities of cheaply available oil in the form of air conditioning systems or heat recovery units or even triple glazing. These technologies are neither durable nor are they expected necessarily to last. And most contemporary buildings require specialist knowledge and equipment to maintain them. This is knowledge which is easily lost. It might be economically inaccessible to people, and it depends on parts which readily go out of production. This technification of architecture has concentrated power in the hands of the technocrats. Our current material culture transforms vast quantities of extracted materials into vast quantities of waste, and it does this extraordinarily efficiently. We exist now in the oil age of architecture. The circular economy is the idea that in order to think meaningfully about sustainability in relation to human production, we need to consider the entire life cycle of everything we produce. So embedded in this are three key material cycles: composting, recycling, and reuse. William McDonough, who was one of the authors of Cradle to Cradle, the founding text of the circular economy, recently developed the Innovation for the Circular Economy House, This is a building system made entirely of polycarbonate, aluminium, and aerogel. These very high energy and high carbon building materials are justified by the idea that the system is designed to be demountable, meaning it could be reassembled elsewhere. But due to the number of components and their complex dependencies, implementing reuse and recycling in construction in a meaningful way represents an immense and potentially insurmountable logistical challenge. Ultimately, it demands vast warehouses, distribution networks, and mass standardization. It also has to acknowledge the inevitable entropy and significant loss of energy, carbon, and functionality along the way, and also the significant energy required to redistribute and recycle elements. But if you think about those three cycles I mentioned, composting, recycling, and reuse and recycling broadly receive the most investment. And we think this is because reuse and recycling maintain the logic of capitalist growth. It's a fanciful narrativization of the future which justifies the continued use of high energy materials that we have become so dependent on, and it allows us to maintain the status quo. Reuse and recycling again very quickly become highly technocratic. Standardization means fewer authors, and we lose sight of architecture as a crucial mode of cultural production, and we further consolidate the almost total monopoly of the white male technocratic author. The reality is that the circular economy is not possible with the materials we are currently dependent on. So what's the alternative? How do we respond to the evolving needs of a society without the disastrous effects of our current modes of production and growth? Nature deals with waste in other ways, through composting and fermentation and decomposition. And these are processes which reintegrate matter into natural carbon cycles where it has the ability to regenerate and regrow. So in material cultures, we're interested in what happens when we work with construction materials that can remain part of biochemical and nutrient cycles. A mode of construction where at the end of their life, the constituent parts of a building could simply return to the ground. Materials which aren't contaminants, they belong to the landscape. This is how we made things for thousands of years. These materials have an inherent plurality. They can accommodate many standards and many authors. In fact, bio-based materials will sequester rather than generate carbon. They're accessible and they require few specialist tools, and you can use simple detailing and a kind of intuition when you work with them. And they allow architecture to be culturally generated. And perhaps they suggest a different type of relationship to a building, situating architecture in relationship to care. And this is a care which requires human investment and a different set of relationships to place and the formation of new cultures. Bio-based materials could be produced efficiently at regional scale, and they can integrate with existing crop cycles. So the other implication is the possibility of architecture rebuilding a direct relationship to place, which means things traveling less far and it being much easier to return and assimilate them back into an ecosystem at their end of life. You could see a building as a gathering up of different parts of the landscape. And coming straight from the ground, these materials invite direct contact and experimentation and play. This is at the center of our practice, because we think there is a huge amount still to learn and also to relearn. And that maybe a new relationship with materials is a way to find new languages for our buildings, which have the potential to supersede those that we've inherited. We're aware our approach might be considered Arcadian, but we're also interested in the role of contemporary tools and modes of construction, which means we work with building offsite where possible and with efficient forms of mass production, because we know the problem is massive and it needs to be met at scale. In order for change to come quickly enough, the status quo needs to be challenged on ecological and economic terms, which means embracing digitized construction processes where repetitive and non-specialist labor is carried out by machines. Off-site, we have the ability to improve working conditions and to change construction cultures and to reimagine factories as sites of creativity and cultural production. So we're interested in how these ideas can scale to the size of a town or even a city. But I'm going to talk about two projects we've been doing in the last year to start with. And the first is an exhibition project which we completed in last autumn for the Design Museum in London. And it was for a show called The Waste Age, What Can Design Do? The show is essentially about our current relationship to waste, the potential for its toxicity and how we can reuse waste. Sorry, there is actually a storm going on outside now. And what it might mean in the future for us to exist without waste, or what's a post-waste society like. So the exhibition itself was forefronting the work of scientists and designers who relate to and work with the issues of reuse and recycling. And our brief from our client was to design the exhibition with this agenda of waste, but also of low embodied carbon construction in mind. So the way that we work through this, this sort of brief is we begin with a palette of materials, of kind of a set of potentials. In this instance, things from lino to cork, composite fiber boards, adobe, and we sort of have a sort of broad spread of a palette which might be appropriate. And then we start to assess these materials as we work with them, looking at them in the abstract, which has its failings, but we look at the materials in terms of their impact on the environment. This is a tool called the Material Pyramid, which we did not design, which is fantastic. You can access it online. And it sort of hierarchies materials based on their global warming potential, their impact as a kind of carbon dioxide equivalent through the processing of these materials. What it doesn't give you a sense of is the impact that material has once it leaves a factory, and so in terms of how far it has to travel to your construction site, and the way that you build it and what you do with it at the end of its life. But it's a really useful way of giving you some kind of abstract hierarchy between materials. And it's not just in terms of their impact on the environment that we assess what we pick to work with, it's also their cost, and then again, their distance traveled to site from source, and then what will happen to them at their end of life. You know, how easy is it to take something apart with this material fixed to this material? So with all these different factors at play, and principally almost always budget becomes the most important one, we started to make choices for our client with them as well around the palette of materials, which would be efficient to use and simple, and also kind of spatially rich, and start to talk about what it might be to have a future without waste. So our brief for ourselves was that the structure could essentially compost if at the end of its life the materials get reused and reused. The very last step is that they can return back into a kind of carbon cycle. And we settled on a palette of adobe blocks and bricks, which are made in Buckinghamshire, clay plasters, wood wall boards, and a prefabricated timber I-joist. And we inherited from the Design Museum a whole host of calcium silica blocks, which is this white block in the foreground, from a previous show, which we reused again. And we conceived essentially of a sort of temporary infrastructure within a very high specification environment. The world of art display and museum context it's a different place to be using natural materials, but it felt like an important place to demonstrate that you can use them in that context. And the cultural industry is, broadly speaking, extremely wasteful. Exhibitions go up and they go down and the materials get skipped. So we used, in this instance, here we're looking at the adobe wall with a fired brick detail. And we've essentially introduced two spatial moves into the exhibition space: a cassette system of timber joist and wood wall panels, which is prefabricated, and then a curved adobe brick wall on the right-hand side. And we introduced a single fired course of brick for fixing and hanging pieces to, and occasionally we rotated the adobe blocks to form shelves or plinths for display. And within the cassette systems, we lined out the wood wall panels to form niches for display using beautiful clay plasters, which were pigmented with ash. And then we looked at the different spaces which were created by intersecting these very simple forms, what they would create and what how you'd move through the sequence of spaces. And this is how the cassettes were designed to come together and also ultimately to come apart. So all of the pieces could be unscrewed and hopefully be distributed at their end of life. And we worked through mocking up these cassettes on site. And also crucially and really interestingly, we worked with environmental consultants throughout the process of the exhibition design, consultants called Urge, who audited us in terms of not just our material choice, but also how many times we traveled to site and how we traveled, how many emails we sent, and what the electricity bill we had while we were working on the project was, and our energy use. So they really audited the whole process of the design and installation. which is really extraordinary and a really interesting process. I think it was certainly the first time the Design Museum had gone through an audit in such detail, but it sets a great precedent, I think, for cultural projects, that they should be assessed by that criteria, as well as the quality of the spaces that you create with them. And this is the show as it was fully installed. And here we're looking at the precious waste space with lots of the pieces that were designed for the fashion industry, using kind of the reuse of textiles and cloth. And just some more of the images of the space, the installation. And I will move through very quickly. So we're interested as a practice in the different scales that we can work at. You know, that's a tool for us, I think, the exhibition design, because it attracts a different audience and engages a different set of people. And the impact that the built environment can have has all these different scales, and scale of the city, but also has unintended consequences. And the work that we do looks to interrogate those consequences as much as we can. You know, there are limits to our knowledge, I think, but we find consequences at the scale of the material, particularly at the scale of the building. When you assemble that material into a built structure, what that does to the language of our cities and our streetscapes. But then also, if you look again at the scale of the landscape where that material come from, what has your choice as a specifier meant for somewhere else? Like, what have you displaced in the action that you take at your desk? So I'm going to talk a little bit now about a research project we did last year, which examines those three scales more specifically in the British landscape context. So last year we worked for the North East and Yorkshire as a region to develop a strategy for a bioregional construction economy alongside our partners at Arup. So this research was funded by the York and North Yorkshire Local Enterprise Partnership and the North Eastern Yorkshire Energy Hub. And we looked for our client at how to enable the production and take up of bio-based products, and how agroecological processes might be integrated into a transition of the construction industry. We also asked then what the impact might be of doing that on our landscape, from the potential benefits of a transition, as well as the limitations of one today. So this is a sort of broad snapshot of the North Eastern Yorkshire, which is an expansive part of the United Kingdom. But across the region, the local authorities in these different districts are pulled between a very clear divide: the drive to develop land on the one hand for housing and commerce, and also to preserve our landscapes and the biodiversity within them on the other. So it's this intersection which we were really interested in, the intersection of the climate crisis and the housing crisis. And that's what our research in this region addresses. So we estimated that approximately 30,700 homes a year need to be built across the region, or 500,000 homes by 2038. In embodied carbon terms, that would be more than 26 million tons of embodied carbon if we built those homes in the way we build them today. Now, a bioregional construction economy means essentially that you work with bio-based materials. And we investigated what these essentially regenerative materials are and what they could be if they were sourced within Yorkshire and the North East, looking at what activities already take place. And we found that there is a burgeoning industry, feedstocks which range from timber to hemp and straw. And there are lots of exciting new businesses in the region which are already growing those materials, manufacturing them into products, and innovating in an otherwise extremely conservative construction industry. And some of the areas that we looked at have some of the highest levels of deprivation in the country. So expanding the region's capacity to produce and use these bio-based materials could help tackle inequality within the region, provide new farming opportunities, new jobs in rural areas, as well as contributing to the number of processing and construction jobs that you have across the region, where there has been a very sharp decline in skills and employment. And if we look at these materials at the scale of the feedstock, something like hemp can be a really great addition to a landscape. It provides direct biodiversity benefits, very simply because when you grow a crop of hemp, you don't need to put pesticides on it. It's so virulent, and that improves the soil and increases the yields of some of the follow-on crops. So if you have a field of hemp and then 3 months later you put some wheat on it, the wheat will do better because the hemp was there beforehand. They're also really low in embodied carbon, these bio-based materials, which I keep alluding to. They sequester carbon dioxide while they're growing. And because they're plant-based materials, they're also renewable, and they can therefore help to support a circular economy. And so very simply, substituting carbon intensive construction materials with regenerative resources from the biosphere is a really key approach now to decarbonising our built environment. And at the scale of the building, we looked at the impact of taking these bio-based materials and applying them to a generic housing typology. So we looked at the new build 3-bedroom semi-detached house by an unnamed developer, but you could probably guess which one. And we found that these materials in the context of a home can create healthy environments for the people that live in them, but also along the supply chain from the people involved in their production and application to the end users of the spaces that they create. So we did a very simple swap. We substituted a conventional pallet of concrete block, PIR insulation and plasterboard with timber frame hemp bat insulation, which is a kind of floppy hemp fiber version of rock wool, but natural, and a new lining board product, which is a lime and hemp lining board being manufactured in the UK, which uses the waste from hemp processing as an aggregate. And we redesigned the envelope of this very standard home and looked at what the wall buildup would be of this house. You know, it gets thicker, but we made sure that the two houses were comparable in terms of building regulations and building standards. They perform the same. We also picked those materials very simply on the basis that it's a palette which exists today. It doesn't require reskilling construction workers, and it doesn't really require a change in understanding of how you build. They're sort of skills which exist. We're just doing a kind of sneaky swap. And the impact of the substitution is that you get 198% reduction in the embodied carbon associated with these components, which is equivalent to the energy consumed by 4 UK households in a year. That's per house. So if you extrapolate this across the region's housing need, we could be saving something like 2.88 megatons of carbon dioxide equivalent by transitioning our industry to a bio-based one just in the Yorkshire and the North East. Predominantly, you can see that's because of the green, it's because of the biogenic carbon. So what the carbon which is sequestered in the house, in the plant materials. And what I should say, and I neglected to mention, was we didn't change the foundations in our study. I assumed they were still concrete, because I guess there are some assumptions and some changes that you have to accept that the construction industry is going to be slow to enact. But this is a house it could build tomorrow instead of that house on the left-hand side. And if you zoom out again, and one scale up to the scale of the landscape, what would it mean to grow and manufacture these materials? Would that mean an era of much more industrialized agriculture than the one we're just leaving? Increasingly, farmers now in the UK are looking at much more diverse methods of farming, which involve growing numerous different crops in close proximity to one another. So this diversification offers them alternative revenue streams, but also benefits to ecology and biodiversity. And bio-based materials can be grown in this way alongside existing crops and dovetail into existing rotational systems. So we look at the northeastern Yorkshire as a region. This is a kind of crop of the United Kingdom at the neck where it meets Scotland. You can see that there is not much woodland cover. It has one of the biggest forests in England, Kielder, on the border with Scotland at the top. But otherwise, yeah, forestry is not one of our great strengths. But there are significant areas of grazing land, which is shown in yellow, and arable farming shown in brown. This is, lots of the land is dedicated to sheep farming, essentially. But farming is the most substantial industry. And in our research, we found that looking at those existing land uses, changing to a bio-based construction economy doesn't actually require much change to the existing land use. Substantial afforestation is already proposed across the UK. But what's really crucial is that when we plant these new trees, we do it much more quickly than we are, but also that we develop a culture of productive woodland alongside national parkland. There are kind of two factions in forestry in the UK, people that like to enjoy forests as recreational resources, but also for their biodiversity and ecology. But then there's the kind of the construction industry and the productive use of woodland, and they are at odds. But we will need both if we wanted to transition our industry in the way that we talk of. But if we look at the areas of woodland needed to supply the structural timber for this housing study, these are really small fractions of the existing forests. So we need about 3.4 kilohectares of timber to meet the annual housing need of Yorkshire and the North East. That's a small white blob inside, just represented inside the mass, which is Kielder Forest on the borders. And if you were to grow the insulation and lining materials like hemp or straw, that doesn't actually represent a dedicated land use. Straw is a byproduct of producing wheat, and hemp is a rotational crop. We're talking about 3 or 4 months, a year of cover before you switch to your next crop. So although you need significantly greater areas of land, that's not a dedicated land use, and food production can still carry on as normal. And the lining board product we looked at uses waste from the production of the insulation. So although the area of land that you need is much more significant to produce that waste, it's a tertiary byproduct essentially of production of other farming products. So we're looking at very small fractions of land to shift tomorrow, basically, to this different way of building. But essentially what we understood was that there were significant benefits. There are different cultural factors at play which limit this transition. In terms of the significant benefits, the economic value generated for the region over the next 15 years alone of shifting the way we build could range from between £5.5 billion to £14.8 billion. And in none of those scenarios did we ever assume a 100% transition, because that seemed extremely unlikely. The most ambitious scenario is talking about a 40% uptake of housing stock being built in this way, but generating new industries around that, which is obviously extraordinarily beneficial. And so what's been stopping us is the real question, because in many ways it seems like an obvious answer to a complicated question, but there are many more complex reasons, unfortunately. Regulatory frameworks is one of them. This is very specific, some of this now, to a British landscape context and a British construction context, but many of these factors, I think, are global. We understood from the people we were talking to that there's sort of regulatory frameworks which stop startups entering the market, but also the fact that planning policy and the building regulations don't support using materials in this way at scale is inherently very problematic. You aren't penalized for building bad quality buildings, and by bad quality I mean high carbon. The finance system in the UK around housing is also a seriously limiting factor. So you need to get a structural warranty to build a new house, and a structural warranty is subject to insurance, and your insurance is then what facilitates getting a mortgage. And essentially the mortgage industry is very risk averse, which means building the sort of building that we speculated on at scale today is impossible if you needed to be financed to do it. There's also just a whole host of misconceptions, I think, around what these materials are like to work with, what the consequences of using them are, and how safe they are as well, very simply, I think. But there are opportunities too. We think that regenerative farming is an opportunity. In the wake of Brexit, there have been significant changes to UK agricultural policy, but also across Europe, there's much more of a shift towards agroforestry practices. And in that, we're talking about things which mean trees and crops, both things which could serve the construction industry, being brought closer together and serving better biodiversity within the landscape. Skills and jobs at the moment are a limiting factor, but they're also an opportunity. We could be upskilling our workforce and giving them jobs that could last, that are skills which we need for the future rather than skills which are on the decline. And we have construction technologies today which could offer us all sorts of abilities to make these materials and systems more economical over time, because also we have to accept that today they are not, because they are not being supported by global supply chains which are very, very efficient. So our primary conclusion was that without state support, a low carbon construction industry in the UK will always be regional and small scale. But the future of a decarbonised built environment now depends on previously disconnected industries working together to facilitate systemic change. So our question now is, how could these different and competing demands on our landscape be reconciled in a post-carbon future? Because the landscape of the UK is subject to a multitude of pressures, and many of them are considered to be in direct conflict with one another. Are our fertile soils better dedicated to grazing land or to arable farming? And how can reforestation and afforestation serve us and our landscapes ecologically, but also benefit the tenant farmer who has for a long time been compromised by the systems we put in place? Now, whilst the climate crisis has finally reached our headlines, the housing crisis persists, and it presents additional complexity to the decisions that local authorities have to make to meet our commitments to reach net zero. And added to that, growing our new bio-based materials for the development still to come presents a reimagining of land use previously unanticipated at scale. Recalibrating our landscapes away from extractive practices towards a new model of land management, which fosters regenerative resources, is an exciting opportunity for construction innovation. But our question now is, what will this look like? Could our farming landscape draw more from agroforestry practices and bring greater biodiversity into the landscape alongside smaller mixed rotational farming? With sustainable forestry practices which facilitate the development of productive woodland and national parkland. We know that our current economic modus operandi can't support the kinds of futures we envision for ourselves and for those to come. But as architects and builders and citizens, we have to urgently rethink our relationship to the land and to each other, and to form new forms of material practice and culture and economy in solidarity with people and also with our landscapes. Thank you very much.
Oh, thank you very much, Summer.
Thanks, Summer. Yes, thanks a lot. It was really exciting to listen to you, and because you operate on so many levels and you do this, you really get the hands into the mud, and not only in a literal way, but also into economics, and you try on all scales, but also in different political and social dimensions to investigate and realize these ambitions, which are so important for us, because as you said, we all have a choice, and now is the time to rethink these topics. And I guess it's also useful to operate with many formats, like you do research, you do exhibitions, you have your you liaise with engineers like Arup. I wondered, because you have been developing those ideas already for a while, has the climate changed already for this? And do you feel it's getting at least a bit easier, or there's more and more appetite for supporters to help you from the industry? Because especially in the UK, it's an industry of building systems that the architects are putting together. And that's why the system is so inert and maybe difficult to get in. But do you feel that there's some partners that you can get onto your side, and that there's already initial things of times changing towards your side?
Yes, I think the answer is yes. Although which climate is changing is a good joke. Yes, the climate is also changing. But in the construction industry, I suppose it depends which conversation we're having on which day. There's so much fantastic advocacy work, when by no means the best advocates. There are, groups like ACAN, and they have all sorts of strands and working groups, and they lobby and get involved with all sorts of different elements that can, introducing natural materials to the construction industry. So that feels very heartening, and that they do some fantastic work. Also feels like that starts to percolate into the construction industry in a really positive way. I guess there are places where it doesn't feel like it's changing very quickly, or as quickly as it should. And we're interested in the mass house builders because they have, maybe you could argue, the most impact on our land, and what our land looks like, but also the kind of environmental impact of the construction industry. Proportionally, they build a lot. And the conversations that we have tried to have with them haven't exactly been super successful yet, but we keep trying. But it feels like they're kind of incubators. It's just that the scale of the change isn't happening remotely quick enough. But we know so much more now about the impact that we're having. But it's so hard. There are so many infrastructures in place to unpick that in many ways we sort of need a full overhaul. And that's something we talk about a lot in our practice with George and Paloma, is the question of kind of reform versus revolution. What are the tools we have to hand, and maybe we need a revolution, but maybe we're only enabled to reform one action at a time. And it's also the training of an architect, isn't it, to sort of problem solve with what you have in front of you. Sorry, long-winded answer to your question, but I think it's getting slightly better.
That keeps us going, definitely. Yeah. I forgot to mention that there's now, of course, also for everyone listening, the opportunity to ask questions, which we will read out loud. So please do go for it and just type in whatever you're interested to engage with us.
Summer, I was wondering, some of the materials you used in your prototypes, also in the exhibition, for example, let's say the hemp insulation or hemp bricks, something like that. Do these materials lend themselves to an industrial production process? Or like maybe phrased differently, why aren't these things being picked up by the industry?
I'd say the first thing is that they are more expensive. Sadly, a year and a half ago, I could just about fudge that they are cost comparable, but that's not true, and it's certainly not true now. Things are getting so much more expensive, and the construction industry supply chains around things like concrete blocks are so extraordinarily efficient. I mean, they're just amazing. Concrete is made everywhere. If you try and find a concrete packs mixing plant, there is one within arm's length of any direction that you stick an arm out. They're amazing. And there's just economies of scale, they're extraordinary. So cost is really crucial, and it comes up for us all the time with clients, and we're lucky we have clients who come to us because they want something that is low impact, but those clients are not all clients. The other problem really, I think, is that a lot of the materials are just as easy to use, and even where they are cost neutral, they're just not what people are used to. And I can't speak to other construction cultures in Europe, but in the UK, the culture is very conservative. So, we worked on a project which was building a building out of hempcrete block, and they were just used as an insulation on the inner line of an envelope. So really all you had to do was cut them up and glue them together with lime mortar. I mean, if you use a bandsaw, it's very straightforward work. It's not very, it's skilled that you have to work with the lime, but otherwise it's not, unimaginably complex. And our contractor had just never heard of hempcrete before. And they looked at them and they looked like a rigid block, and they priced the whole package like working with a stonemason. And which was very expensive, because if you try to line out your building with solid stone, imagine how much that would cost you. And we had to take that package. I had to pull out that package from the main contractor's works and find somebody who worked with lime, and we got them a bandsaw, and it cost a tenth of what the contractor had priced. And that's just like, they just couldn't be bothered. It's not what they do. They didn't really want to do it. And so it's sort of like, you can counter that at all the scales, at the scale of an individual, but all the way up to the scale of a developer. It's not what they've done. So why would they change it? So there's a lot of inertia, but otherwise, no reason at all. It's a great answer.
I mean, it's obvious that these many of these materials are more expensive, but then, the reason why they're more expensive is because they're not being produced at an industrial scale, and not because no one wants them. And obviously, when you start producing a new product, you take a risk. But I was wondering, because obviously many of these materials, when we talk about them or when we look at them, they do have a kind of manual labor feel about them in a way. And I was wondering, is it really like that? Or would a hempcrete block be, if you scaled up the industrial production, would that in the end be as cheap and as easy to produce as a concrete block?
I think I feel pretty confident, but I'm not by any means an economist, but it's demand. The issue is demand, because inherently those things, even simply, if you were going to quantify, the lime just doesn't get fired to such a high temperature, so it must cost less to make lime than OPC cement. I would propose. And the shiv is a waste product, where you use the hemp for. It's not the valuable part of the plant, because the fiber which makes clothes is pretty valuable. The seed and flowers which make the oil is quite valuable. So I would propose that they could be low cost, but it's a demand issue. But they do lend themselves to industrialization, just like anything. All of the things we work with come from the land. We work with at the moment the minerals more than the plants. But I guess if you were going to scale things up, the lighter weight, easier ones are easier to to imagine. So the hemp bat insulation that we proposed in the report is a much quicker fix, because hemp block is labour and people don't like laying bricks and blocks in the UK anyway already. It's not so commonly valued as a skill. But yeah, it feels very possible, I suppose. It's just, in the end, we always come back to the cultural limitations of change more than the economic or the practical limitations.
Maybe a question from the audience. Question is there any material which is underestimated and which you discovered during your work and during your project? Or like maybe also material qualities that you didn't know about before?
Interesting question. I've really come to be a huge fan of straw, which I wasn't expecting. But I guess the work that we did on this project, we met a fantastic woman called Barbara Jones, and she does amazing work working with straw buildings in the UK. And it just felt like, of all the questions that we were asking around the impact of what you do on the land, straw was the most obvious answer, because I love lime. I mean, there's so many fantastic materials are available to us, but you can't get around the fact that to make hempcrete or to work with lime, you have to fire to quite high temperatures. It's lower than cement, but reasonably high. And stone, we only have so much stone, so we keep cutting it out the ground. We're making a bit of a mistake. And clay, you have to fire to make bricks. But all of these things are quite energy intensive. We make wheat anyway. We eat so much bread. And then straw. I mean, it depends. The argument then about how you work with straw and how you make it sort of fire safe is a sort of different question, because then you sort of come back to lime and clay to cover the building up. But straw is essentially a waste product from farming. As fertilizer prices are going up because of the energy crisis, the value of straw as a natural fertilizer has become more important to farming. So then it's not so much of a waste stream from farming, and it has another use. But that kind of push and pull will always exist between what we want to build with and what we need for other uses. But it's just a very low energy thing, and it makes you ask different questions about buildings, because you have to make your walls like as thick as a straw bale. You know, we're kind of going back to castle culture and super deep reveals, but they're really interesting. They're different answers to the problems, and you stop thinking about things as being skinny walls, and you just get used to the fact that everything's really, really fat, but kind of extraordinary, because you could just take it from any field. You know, the supply chain is so much more local, it's hyper local. Even with things like lime, you need to find a kiln, and there are not so many in the UK.
Another question from the audience is related to the potential lifespan of the buildings you're proposing. Have you, I mean, obviously this is like a process, and buildings need to be watched over time to see how materials age and like what you need to do to maintain them. But also, you're not the first people to ever use hemp. What have you found out?
Or straw. I mean, you know, there's like medieval buildings that are still standing, like timber roofs on churches and cathedrals. So yeah, there's ancient structures by our standards, our ability to think of time. I mean, hempcrete hasn't been around for centuries, maybe decades, and all those buildings are still perfectly fine. I mean, there's so much lime in hempcrete that you really are making quite an inert structure if you look after it well. And I think there's also, increasingly, I think there's some serious misunderstandings of what it is to make a contemporary building and how long contemporary buildings last. You know, it's expected that a new building will last longer than one made of natural materials if you have a plasterboard and steel frame, but that's not the case. Actually, so much more about buildings which don't breathe moisture makes it very important that they're built well, and that relies a lot on quality control and care and good design. But also the warranty systems that we exist within, where you have materials that get warranted for a period of time. You'd be astonished to find out what the warranties are, the things in the room that you sit in, but they are not that long, actually. And we had a really interesting meeting recently with Rota DC in Brussels, because we're looking at now at a kind of circular economy hub for Newham in London, and they build brand new, as far as I'm concerned, stone cladding off facades and turn it into flooring and tiling. And they said that buildings in Brussels have their stone cladding changed every 20 years because the warranty runs out. Now, that is an extraordinary amount of time for something which has been under the ground for millennia and is totally fine. 100%, there is no problem with that material at that point. It's not the stone that's failing. It could be the workmanship, it could be the metal cladding rails, sure. But probably it's uncertainty and risk aversion that is taking that stuff off that building and now making some very expensive flooring for no reason, because it could still be cladding.
And it's the construction industry who are writing these regulations, right? Because they want to sell more stone. So
exactly,
it's like the same reason why the iPhone breaks down after 2 years.
Exactly.
Okay, yeah. I mean, that's crazy. And especially what you mentioned earlier about if you want to build a house in the UK and you need to finance it, that's not possible with certain construction methods. It's completely ridiculous. And I mean, what you're saying about how conventional buildings age, for me, aging also has a lot to do with adaptability. Mm-hmm. And for example, always discussing windows with clients, and like a timber frame window, after a few years, when it doesn't look so good anymore, you can sand it down and repaint it, and it's like new. And there's like here in Germany, everywhere there's buildings with timber frame windows that are hundreds of years old, no problem. But a plastic window is just broken after 10 years, and there's nothing you can do to fix that. No. And nothing you can do to refresh it and to adapt it to anything. You need to take it out and throw it away.
And all the parts are so hard to bring apart. This is a bit of a sidebar from construction, but because we're looking at reuse recently, we've been speaking to some scrap metal recyclers in the UK, and they told us the way that they recycle cars. I had no idea, but they just put the whole car through a shredder. No one pulls anything apart. Just the whole car just goes in at one end of the construction of the conveyor belt, and then just comes out as pulp. And then they separate out the metals with the magnet, basically, and then they send the steel off to Europe to be resmelted. But all the plastic and the cushions and the bits, all of that just ends up as completely useless dust, because how on earth do you take that amalgamation and turn it into something separate and new? Anyway, so windows. Imagine what happens to plastic windows. Imagine what happens to that you can burn off the interlayer and double glazing, but even double glazing is not a simple thing to take apart.
Yeah, absolutely.
There's a really big cultural, educational aspect to what you're doing, and I think it's so important to build these prototypes to demonstrate that the current expectations and prejudices are wrong, and they've been driven for decades for a particular industry. And that, as you've shown, traditional ways of building without mastic and plastic joints have a tradition and can actually breathe, and when they're not sealed. And I guess your way of thinking also demonstrates a flexibility in applying different materials, because like in Germany, there's an expectation, I want my house out of brick, and that's it. And if it's solid and it's heavy, and then it's a good house. And there's an interesting study by Florian Nagler, who did 3 houses under the title Simple Building, one with brick, one with insulated concrete, and one in timber, and looking at the performances and also carefully calibrating sizes of windows against cooling, insulation, and solar heat. So that's a very interesting case study.
That sounds great.
Your way of thinking is much more multi-layered, and it also shows when we think of rotating or rotor systems and recycle, that composite constructions made of layers are maybe easier to promote because one material in itself cannot fulfill a role. Straw can insulate, clay can be fire protection, and another thing can do this. And as a package, they deliver the wall. And it's not that one product that has been perfected over decades that does it all, which is what many people like, because also it reduces processes. But
Yeah.
I guess we need to be more flexible in how we assemble things. And
yeah, but it's also like you said about the British construction industry. You know, it is very proprietary. So although yes, for straw you need straw, and then maybe you need clay or lime on the inside or the outside, depending on what you want. You could have a timber frame. The simplest version of that building is you have straw, you have lime, and you have lime. But anything else which is non-breathing, you're going to have a block, you've got your PIR insulation, you have an air tightness membrane, probably you might have a DPC as well. If you've got a cavity wall, you've got those little cavity ties, and then you've got those insulation spaces, and they're made of plastic too. And in the end, you've got like 12 things. and that's still quite a simple wall build-up. So yeah, there isn't one solution, sadly. I mean, you could make everything out of hempcrete if you wanted. That wouldn't catch fire. But yeah, but there are simpler ways of building than the way we build today, I think.
I mean, of course, the UK and Germany, for example, or any other country in Europe, all have their very specific sets of regulations and specific ways how construction works legally. Like, in your point of view, from a political perspective, what needs to change in order to make sustainable construction methods more plausible? Because I mean, the politics, obviously, they do have a huge amount of influence on all of this. Not even like starting with subsidization, but even just regulation and what needs to change in your eyes?
Policy is a major one. I guess it depends who the audience is for like our call for action. Policy, funding, subsidizing. We support lots of failing industries, unfortunately. Farming is not doing tip top, but we've been subsidizing it for a long time because of like ideas about national and food self-sufficiency. But there are subsidies which could be being offered. It's just not a priority. And there are policies which we could use to leverage change, because as soon as the policies come, the developers and contractors will fall in line, and these materials will become very quickly much more economical. But as architects, I think the tool that we have most at our hands is the kind of as a specifier. And every time you build a building well, and every time you build a building which uses these materials and doesn't look old-fashioned and Arcadian and performs very well, and people like it and love and think it's beautiful, every time you do that, someone else who's at the same, sitting at their desk, down the line, can point to your building as an example to their client and say, look, well, this is fantastic and it worked really well. And we sort of need that kind of ripple effect of practices taking alternative decisions, actually. As soon as the architects that make those decisions are the bigger ones with more power and more clout, suddenly things we hope will start to change. But yeah, that sort of needs to happen alongside policy and the other kind of economic levers, because you also can't create demand for an industry which isn't ready to feed it. And there's all sorts of chicken and egg loops going on. You can't train a whole load of people to work with those materials if they can't get jobs. And so we sort of have to have all these things going together, softy at the same time.
Great. Thank you very much.
Thank you.
Bernd, any more questions?
No. Do we have more questions from the audience?
Right now, no.
Okay, good. So maybe we wrap it up this way. And thanks again, Summer. I think it will make us all think and question of what we're doing. I think that's the most important thing that I'm taking with me.
Thank you so much for having me. It was a real pleasure.
Thank you so much, Summer.
Have
Goodbye.